you're all doing well this very fine day. I'm architect Untitled and I welcome you all today for this occasion. And we are assembled here for a very special purpose, that is to participate in the deliberations of webinar on energy conservation and energy efficiency. This program is initiated on the behalf of Punjab Energy Development Agency, PEDA, and we are pleased to share that PEDA is celebrating Energy Conservation Week in the entire state of Punjab. Sakar Foundation from Chandigarh has been given the responsibilities of organizing 7 webinars from 18 to 26 February 2021 daily from 2:30 to 4:30 p.m. except for Saturday and Sundays. Energy efficiency describes how much useful work is extracted from one unit of energy. So remember that although energy is not created or destroyed, it is transferred from one form to another. Some energy is nearly always lost in the transfer as heat. And by saying that the work must be useful, subtracts the energy that is lost to non-useful work. For example, some energy may not be doing useful work if the equipment is not running well. In this week-long program, we shall be organizing exclusive webinars for different departments and organizations of government, semi-government, and private departments which are working with Punjab State. So these webinars are specially designed to talk on various subjects like energy efficient architecture, green building materials, energy efficient lighting, HVAC, star labeled appliances, etc. I extend my warm welcome to the members and architects from the Department of Housing and Urban Development, PEDA, Punjab Urban Development Authority, Greater Mohali Area Development Authority, Amritsar Development Authority, Bathinda Development Authority, Jalandhar Development Authority, Greater Ludhiana Area Development Authority, etc. So today's eminent speakers who are invited are special accredited professionals which have great experience in the field of energy conservation and energy efficiency. So firstly, I would like to invite architect Guneet Khurana to give the welcome address to the audience. Over to you, sir.
Thank you. Good afternoon, everyone. Myself, Architect Guneet Khurana, and I welcome you all for this informative webinar. Today's event is organized by Punjab Energy Development Agency, PEDA, with the help of Sakar Foundation, Chandigarh. We welcome all officials, staff members, and authorities of PEDA to this program. We extend our warm welcome to all the officers and staff of Department of Housing and Urban Development of PEDA, GAMADA, ADA, BDA, JDA, GLADA, etc. for their participation in this webinar and other professionals. We also welcome today's speakers, Dr. Harveen Bhandari, Architect Surinder Baga, Engineer Balkar Singh, Engineer A.C. Verma. We highly appreciate them as they have spared valuable time to share their knowledge with us. In addition, we welcome our supporting organizations, Indian Institute of Architects, Chandigarh, Punjab chapters, and also the members, executive members, office bearers of IIA Chandigarh and Punjab chapters. I welcome Architect Ramneek Garyal, who will be comparing this program today. I congratulate all the members involved and hope this event will be beneficial and informative to all the participants. Thank you.
Thank you so much, sir. And now we have Dr. Harveen Bhandari, Deputy Dean, Chitkara School of Planning and Architecture, Chitkara University, Professor and Deputy Dean, Research and Publication in Chitkara and School of Planning and Architecture, and she completed her doctoral studies in planning and architecture in 2019 and MArch in 2011 from Chitkara University, Punjab, and BArch in 2003 from MRSPTU, Bathinda. With vast teaching experience, Dr. Harveen has many research papers published in national and international journals and has presented papers in international conferences. Has been facilitated twice by A3 Foundation, Chandigarh, with Architecture Journalism Merit Award in 2015 and A3 Foundation Teachers Award in 2017. She is an active member of heritage organizations like ICOMOS India and Intact New Delhi. Her areas of interest include cultural heritage, vernacular architecture, and 20th century heritage. And she's here to deliver Introduction to Green Materials. We have Dr. Harveen Bhandari.
Thank you so much,
Over to you,
Ramneek.
ma'am.
Am I audible?
Yes, ma'am, you are.
Okay, so I would like to share my screen simultaneously. Is it visible?
Yes, ma'am, it is. Yes, ma'am.
All right.
Kindly put
Thank
it
you so
on and
much. And a very good afternoon to all, one and all present here. So this is the third webinar in the series of online webinars on energy conservation and energy efficiency. So it's my privilege to introduce the event today. This series is an online webinar organized by Punjab Energy Development Agency with the help of Sakar Foundation, Chandigarh. So energy conservation has often been referred to as the fifth fuel, the other four being the so-called primary or the fossil fuels like coal, oil, gas, and nuclear or hydroelectricity. This emphasizes the importance of reducing the amount of energy used, not only nationally, but also internationally. The simple fact is that the world's reserves of fossil fuels will eventually run out, we all know this, depending on the rate of use, and therefore, if the consumption of these forms of energy is reduced, the existing reserves will last a little longer. Research and experimentation could lead to these reserves currently available, but uneconomic to recover and use being rendered economic, thus extending further the number of years before these non-renewable resources of energy do eventually run out. The amount of worldwide energy reserves and life is variable according to the source of information used. But at the same time, in the not too distant future, maybe less than 100 years, oil, gas, and uranium will no longer be available. Every effort is required to reduce the world's energy demand to cater to this. The earth provides enough to satisfy every man's need, but not every man's greed. This was very well said by Mahatma Gandhi. There are some hard facts on why energy conservation is a must and why this webinar series has been organized. We use energy faster than it can be produced. Coal, oil, natural gas, the most utilized sources take thousands of years to form again. Energy resources are limited, and in special case in India, it has approximately 1% of the world's energy resources, but it has 16% of the entire world's population. Most of the energy sources we use cannot be reused and renewed. Non-renewable energy sources constitute 80% of the fuel used. It is said that our energy resources may last only for another 40 years or so. If I talk in numbers, 75% of our crude oil needs are met from imports, which cost around 150 crore a year. We save our own money if we save energy. Just imagine your savings if your LPG cylinder runs for an extra week, or if there is a price slash down in your electricity bills. Hence, when we use wood efficiently, our requirements for that fuel are lower, and so is our drudgery for its collection. Finally, the energy saved is only energy generated. When we save 1 unit of energy, it is equivalent to 2 units of energy produced. So save energy to reduce pollution, energy production and use account to large proportion of air pollution and more than 83% of greenhouse gas emissions. An old Indian saying, which we all have heard also, the earth, water, and air are not a gift to us from our parents, but a loan from our children. Hence, we need to make energy conservation a habit. Keeping this in consideration, today's entire event, this entire web series for the week has been planned. With that introductory address, I would like to move on to give you a brief introduction on the green building materials. I agree we are all professionals, we are aware, but still acknowledgement and awareness of its use is very important. Why do we need to choose green building materials? Yes, we know it has associated many attributes, many benefits. Energy efficiency, it has recycled content, renewable resources, it controls pollution, reduces waste, but it is a lot of benefit in investing in this sustainable construction because we have a lot of fraternity participating from construction industry. It creates an energy efficient building. It reduces the carbon dioxide emissions, so we contribute to the entire environment of the world, boosts public perception as an environmentally responsible company, a company which contributes to the nation. There are some criteria that need to be followed for selection of a green building material. First point is the embodied energy. This is very important as it is the total energy that is required for extraction, processing, manufacture, and delivery of building material to the building site. So this basically talks about the life cycle assessment. It begins from the material design, production, transport, use, disposal till the life of the building, and finally its reuse. It involves all the energy and also talks about the carbon footprint, the carbon emissions during all those processes. Material efficiency, it basically involves including non-toxic materials, recycled content or salvaged materials, or materials from renewable sources of energy. So basically calls in for looking out for a four-step approach: reuse, recycle, use of low emission materials, and reduce the usage, and again go back to reusing, and the cycle goes on. The third aspect that one should consider for selection of the material is resource efficiency. This means using the Earth's limited resources, but in a sustainable manner while minimizing the impacts on the environment. So there are certain points or checklists which are important, which should be considered, that the entire content, entire material should be recyclable, available from renewable resources. There should be an efficient manufacturing process involved. The availability of resources should be locally available. Not much cost should be spent on importing them. Easily recyclable resources. Then even the packaging product should be recyclable. Durability is, of course, a very important aspect. And the last is energy conservation. Indoor air quality, another important aspect. It means that indoor air quality can be improved with use of non-toxic materials, natural ventilation, effective air filtration, as well as by controlling indoor moisture levels, protect occupants from chemicals, combustion, and all other sources of pollution. If I talk about in numbers also, 90% of our life is spent in indoors. We have such working schedules, and 2 to 5 times more pollution is seen in the indoors. So this is a very important aspect to be considered. And last but not the least, the most important is the affordability of the product or the material that you use and its durability. Moving on to some of the examples of green building materials that are being used in the entire world. Bamboo, of course, can be used in multiple ways. It can be used to construct frames, supports, walls. Bamboo flooring is very in nowadays for every 3 years. In contrast, trees take a longer duration. They can only be harvested every 25 to 50 years, but again, depending upon the tree species. The image shows how beautiful space frames can also be made from bamboo. Reclaimed wood. Building any construction with reclaimed wood is the most environmentally responsible way to reduce the amount of lumber consumption. And this also, all that goes in the landfills and ultimately to save trees. And this kind of reclaimed wood can be easily available, can be easily bought from retired barns or the salvage yard. Some specialty buyers are also selling it now, or some excavation companies where otherwise it is waste and goes only in landfills. Rammed earth, this is one of the oldest durable techniques for building structures. Rammed earth walls or even floors can be used as thermal storage, allowing for the sun to warm them in the day and then release that warmth in the cooler evenings. And this low carbon technique, which leads to very less carbon emission, uses forms in which the soil and binder is placed in layers and then pressure is applied to create a hard and durable surface. So it's no more that soft and brittle rammed earth, but it is, it is a solid product that can be easily used for walls and flooring, and the texture also looks very good. In recent years, cork flooring has become much more prevalent in homes, commercial spaces. This is one of the most sustainable building materials. The harvesting of cork does not harm the tree, and the bark from each tree is stripped up to 20 times during its life cycle. So this has quality is liquids of stone being a world. They are built hundreds of years ago. They are still in existence without much aberration, and stones are put into weathering. They can be used to construct exterior walls, partitions, designer walls, steps, exterior flooring, and it needs no maintenance, absolutely, and the rugged appearance gives it a unique look to. Wool insulation. In place of chemical leather insulations that are much in use nowadays, we should prefer using sheep wool. It is a great natural alternative to the already used chemical insulation. It insulates homes just like the conventional insulation, but it requires less energy to manufacture. One of the most eco-friendly ways to insulate your property, and sheep's wool can both increase energy efficiency as well as will soundproof your offices, your homes, your interiors, wherever soundproofing is required. Recycled steel. This is another product that can be very commonly used, another material to help in energy conservation. To save trees, it provides increased durability for earthquakes, high winds. Builders are using steel beams nowadays for the framing process in place of wood. According to the Steel Recycling Institute, a 2,000 square feet house requires up to 50 trees to build. While if you use a frame made from recycled steel, it requires the steel equivalent to just 6 scrapped cars. So since steel is 100% recyclable, can be used and has no harm associated with it, it can significantly reduce the ecological impact of new construction also. Mycelium. Mycelium is another green building material that is in use nowadays. Mycelium is basically the root-like fibers which are found on the mushroom or as mushroom roots. And a mycologist, Philip Ross, realized that mycelium, if could be formed into nearly any shape, to be used surprisingly as a steady building material. This mushroom-based material can withstand extreme temperatures, making it an organic, compostable alternative to home insulation. Styrofoam and even concrete mushroom insulation boards have been made and have been physically used in many buildings abroad. Low emittance windows. Windows make a huge impact on the amount of energy used to heat or cool the building. So these low E windows are often coated with tin dioxide, and the thin layers, they basically block the high absorbent UV rays, blocking heat without limiting the light that comes into the interiors. So it does not only cut the energy bills, your electricity bills get reduced. Low E windows can also help prevent fabrics and your carpet that has been used in the interiors from fading early. So it increases the durability of the furnishings used in the interiors. Many other green buildings may be used in construction. The examples I have shown were just a few to name some: fly ash bricks, insulated concrete forms, straw bale, earth bags, slate, stone roofing, thatch, natural fiber. So there are a number of them that can be used to make a building green. Just a quick summary. A green building is also known as a sustainable or a high performance building. It is an environmentally responsible construction, which is the responsibility of us all as fraternity that belongs to architecture and construction. This can be designed to reduce waste, use natural resources more efficiently that we are falling short of day by day. It needs a reduced maintenance. The replacement cost over the life of the building is again reduced. So this is again a contribution from our side to manage the available resources, helps in energy conservation because it involves the entire life cycle and the energy involved in all those processes, offers improved occupant health and productivity, have lower cost associated with changing space configurations in the interiors, and provides in for greater design flexibility. So that was a small overview of green building materials and its use and its necessity in today's construction field. Thank you very much.
Thank you very much, ma'am. So we all know a green building is a building that in its design, construction, operation, reduces or eliminates negative impacts and create positive impacts on our climate, natural environment. Green building preserves precious natural resources and improve our quality of life. That Harveen ma'am has so remarkably done in her presentation. So we all know that 5 hours of efficiency and conservation that she already explained, that is diffuse, reduce, reuse, repurpose, and then obviously recycle. And the materials chosen should be sustainable and green, as she mentioned in her presentation. And she also mentioned the accessibility. So that was a very nice presentation by you, ma'am. And attention. Yes, ma'am. And a request to all the audience present here today, we have a feedback form for you. So after the presentation ends, you will have a link in your email IDs. Kindly fill the feedback form. It has like 10 to 12 questions in a yes or no format, and it'll take hardly 5 to 7 minutes. So please kindly do fill the feedback form. Up next, we have our second talk by architect Surinder Baga on energy efficient architecture. Architect Surinder Baga has established architectural organization Sakar Foundation in Chandigarh. In 1984, he worked as chairman of IIA Chandigarh Punjab chapter, chairman of IIA Publication Board, and editor of Journal of Indian Institute of Architects, and was nominated as councillor in Chandigarh Municipal Corporation. He was also chairman of Chandigarh Municipal Corporation's Corporation's Committee for Buildings and Roads. Currently, he is member of Advisory Committee of India's Home Minister and on Union Territories. Recently, he's been appointed as head of Chandigarh subchapter of FSAI and chairman of GEM of Chandigarh chapter. He will now be addressing our audience. Over to you, Baga sir.
Thank you, Ramnik. Thank you so much.
Welcome, sir.
First of all, we are grateful to all our speakers and PEDA and Bureau of Energy Efficiency for giving us this opportunity to create this platform for all our professional colleagues and officers of different development authorities of the state. Today's my talk is on energy efficient architecture. I have already given this talk in the previous seminars also, but every time attempt has been made to change the content of this presentation so that those friends who are repeatedly attending this webinar may not get bored with this. So I will start with a note that all India's and foreign's holy scriptures, there is a lot of emphasis on saving the Mother Earth, saving the environment. On the top of this slide are the, a verse which is included in Holy Purana, the Hindu scripture, where it is highlighted that how important is tree in our lives. And there are many shlokas in Holy Guru Granth Sahib, which are emphasizing on saving the environment. And it says, Pavan Guru Pani Pita Mata Tartamahat. That means, that shows how much importance was given to the environment by our gurus. Likewise, Quran also versifies the same sentiments and same advice to the mankind. And Bible also includes many verses which are pertaining to saving the Mother Earth. If we have a quick look at the historic architecture of India, so you will notice that this township of Mohenjo-daro, which was created in the year 2600 BC, our forefathers have tried to create a township where we have a drainage system, where we have a proper wind direction is taken care, where the dusty atmosphere around was taken care. So everything was planned keeping in view the local climatic conditions. You look at the houses in the Mohenjo-daro township, you see there are small windows, very modern houses and narrow entrances, and there are brick jali was greatly used in the design of houses. During the Mughal period, which was nearly 200 years period, architecture was at its peak, and in most of the projects of the Mughal period, they used water very judiciously to improve the microclimatic conditions. They used local materials. They used many other techniques to keep the buildings comfortable for its residents at that time. You see, this is a slide of Fatehpur Sikri, which was built in Maharaja Akbar's time. It was supposed to be the capital of Akbar. And in this project, you can see there's water is there, projections are there, thick walls are there. And likewise, in the 18th century, in the Jaisalmer, these Havelis were created. We architects, most architects study these Havelis in their syllabus in architecture. The facade is so nicely interwoven with the deeply recessed windows and projecting balconies, and local materials are used. And apart from that, they have courtyards, and they have many other features so that in the sand dunes area, people can live very happily. Similarly, this is the Hawa Mahal in Jaipur, where we all have seen it. There are small jarokas in the balconies, and those balconies get very cool breeze. You look at the wisdom with which these structures are created. In down south, in Orsha, this is Jahangir Palace. There's a courtyard planning, there are thick walls, and you see there are projections. This was done. This is the ancient wisdom which we have in India. When Corbusier came to India, this capital complex was created, this Chandigarh city was created. You see, this is the Secretariat building. It is oriented in such a beautiful manner that it gets proper wind direction. It's facing the wind direction. And you can see the balcony about 12 feet deep. Glazing is not even visible. And there's a terrace garden on top. And in order to demonstrate his concept of sun control, Corbusier built this Tower of Shadows in the Capitol complex. In this Tower of Shadows, he demonstrated what kind of louvers are needed on which direction. So that shows the sensitivity of Corbusier to design the buildings in the Indian climate. He designed this Punjab University's campus, and this is the Adam Block. You can see the close-up on my left side. Each floor is projecting outwards, and hence thereby shading the. There's a small courtyard in the middle, and this building works very, very beautifully in a hot summers. Likewise, this is another master creation by the French architect Pierre Genre. You see there's a huge glazing which is deeply recessed and put in one corner, which is the deepest corner. And there is a skylight you can see, and there is a water pond below. So this kind of architecture, and you can see the white when Corbusier designed this city museum, he opted for double roof. He opted for double roof in the High Court building also. So this was going very nicely, and in the middle of 90s, you know, a trend started where we used to make buildings which are glass clad or aluminum clad, and there are no balconies, and a school of thought was promoted by certain individuals that we need to have architecture which is modern, and under the guise of modernism, we started cladding our buildings with glass all around, and which was never suitable to Indian climate. Now let's talk what is the way out. We all know that buildings consume a lot of energy. A considerable amount of energy is consumed by building sector by way of construction, use and maintenance. Some surveys indicate buildings alone consume nearly 48% of the world's energy. And this is a conceptual sketch which indicates that, you know, we all know that buildings consume energy in heating, cooling, lighting, water heating, and running of places. And what is energy efficient building exactly? Energy efficient building is where we can reduce the demand for electricity by designing it with modern technologies and concepts which are suitable to Indian climate. This is a conceptual sketch which indicates that in a conventional building, you know, fresh air enters the building and it turns out to be waste air. Fresh water enters the building and the waste water comes out of the building. But on the right side, you know, a building is energy efficient if we create some sort of a cycle where we do not produce much waste. This is another conceptual sketch which, you know, in a simpler way indicates what is energy efficient building. In this sketch, it is indicated that we can have trees on the western side. We can protect our windows with projections. We can have an atrium in the middle, and hot air can escape through this atrium, and there should be vents at the top from where, you know, the hot air can pass. You know, when we design any building, we experiment with different plan forms. You know, different studies are indicating that compact buildings consume less energy. India is divided into different 5 climatic zones, and each zone has its own design strategies, and the zones are cold and cloudy region, which is Kashmir and Himachal parts, and composite region is shown in this map, is shaded with a golden color. Hot and dry region is shaded with the red color, which is Gujarat and parts of Rajasthan, etc. And warm and humid region is the coastal belt of India, and moderate region is a small pocket, you know, near Pondicherry. And first of all, we are going to discuss about composite climate, and composite climate is covering major portion of India. You can see in this map, and Punjab is also. We have certain design strategies for designing buildings in the composite region. What are those design strategies? They are we have to resist heat gain in summer and resist heat loss in winter. How we can do it? We can orient the buildings with longer axes in the east and west direction. We can have roof insulation, wall insulation. We can opt for cavity walls or thicker walls. and so on. And likewise, we can promote heat loss in summer and also in monsoons. How we can do it? We can provide courtyards, we can have wind towers, and we can have a nice arrangement of openings to facilitate heat loss. And by following these principles, we designed a Baptist church in Chandigarh, and this church is rated as one of the best 41 buildings by the Ministry of Renewable Sources. And in this church, you can see we have used light color on the exteriors. Windows are very small, and windows are deeply recessed. The top vaulted roof is painted white so that incident sun rays can get reflected. So with all these parameters, with all these design features, the building remains comparatively much cooler in summers in comparison to the other conventional buildings in the vicinity. You can see there is a cavity wall which is all around this building. And likewise, we designed a Bal Bhavan in Mohali in Punjab. Here, this is the western side, and we have provided, there's a requirement of large number of toilets because this building is utilized by students most of the times, and students live in their dormitories, and we need to have large number of toilets. What we did is, western direction is not considered to be good direction because it gets heated up in our climate in the evenings. What we did is we have given all the toilet blocks on the front side, so that during the evenings the heat gets absorbed in the toilets only, and dormitories remain comparatively cooler. In addition to that, you can see in this building all the glazings, all the windows are properly protected and there are terraces to sit outside, and no window is open to the sky or not shaded properly. All the windows have proper projections. Then we got a project in a competition, that is Yadvindra Public School in Mohali, and this was a competition project, and we have won this competition because the design guideline given by the client was that we should not cut a single tree, and the site was dotted with large number of trees. And this school belongs to the Chief Minister's family, current Chief Minister of Punjab, Sardar Amrinder Singh, and his mother, Rajmata Mohinder Kaur Ji, was the chairman of the jury where I gave the presentation. This existing school is designed by a very famous architect, J.K. Chaudhary, and J.K. Chaudhary was the architect, many people may not be knowing, who designed IIT Delhi and who designed Punjab University campus. He was the original architect of this school, and we opted to have architecture extension of the existing school in such a manner so that the new building merges with the existing campus. That kind of architectural vocabulary which we have chosen. And then in the design of the interiors, we have a corridor in the middle, you can see in this picture, and cutouts are on the sides. These cutouts facilitate the air movement, and we get a lot of light from the top. And these cutouts also insulates the classrooms from the noise which is emanating from the corridors. And this school works really very well now. Youth Hostel PEDA is another project done by us. Here, we have opted for very big balconies, meter deep, and you can see all the glazings, all the doors, the major doors and glazings are deeply shaded, and balconies are slightly segregated so that they can have proper privacy. And in the what we have provided sports on top. Combination of horizontal and vertical louvers, Hello. You can see the model of this school. We have given 2 large courtyards and 2 small courtyards in this school. It sounds very traditional concept, but this is the need of the hour. And as a result, this school is climatically is one of the best model, and it is published in many leading journals. And after that, we got a chance to design a big project, which is the hostels for NIT Kurukshetra. In this project, we opted to give students small balconies. We about 1,200 students were to be accommodated, all PG students, and each student gets a small room with an attached balcony. And we opted to have small balconies, and these balconies are shielding the windows also and the doors also. And we opted to have thick walls. And this is how, you know, many cutouts are given in the corridor areas to facilitate air movement. And you see these curvilinear balconies are protecting the windows. Then some time ago, we have participated in a convention center complex, which was meant for the Ministry of Agriculture of Government of India. In this project, we tried to have a roof which is made of solar panels. In addition to that, we have ensured that no tree is cut while designing this project. Then we have taken care of other features like rainwater harvesting and many other points. As a result, we could create a structure which is considered to be better than other architects, and we got first prize in this competition. The different plans of this, and a very small project but very innovative to my mind. Is a library in a remote village Lopo in the Moga district. In this library, there's a water cooler placed on the top. You can see in this picture. This cooler cools the air, and the cooled air is drawn to the interiors through ducts. And the building is facing east, north and south, and having small openings which are deeply recessed. Even the book racks are designed to be placed alongside the outer walls, because book rack itself works as an insulation material. That was the motive. And on the eastern and the western directions, which is on the left side and the right side, we have given cavity walls. And as a result, it turned out to be a green library in a very small village. Next zone is hot and dry. In this, we designed, the design strategies are resist heat gain and promote heat loss. This is the design strategy. And we designed a housing project in Jaipur for the Indian Army, where we built nearly 800 houses. The orientation is kept north-south because that suits the dry climate, and the color scheme is chosen to reflect the heat, and the balconies are there, projections are there to shade the windows, self-shading facades, trees are not cut. And next category of the climate zone is warm and humid, where we happen to design some youth hostels in West Bengal, Odisha, and Assam, which is falling in this zone. And here in all the projects, we ensured that there's a need for a lot of ventilation. And this is the hostel we designed at Guwahati. In this particular project, because of a lot of rainfall and other reasons, we have given great finish on the exteriors, and we ensured that there's a lot of ventilation which is ensured. And water sports are provided because you get a lot of rainfall. Then in a moderate zone, the design strategies remain by and large the same, but the climate is comparatively less harsh. And this is a house designed by architect Vijay Narnapati. In this house, you can see there are earth berms, and the roof is made of solar panels. And there are many other features like insulated roof, cavity walls, and so on. And in a cold and cloudy region of India, which is this is the region where the design strategy is just required to be opposite, because here we need to resist heat loss and promote heat gain. In this, we designed a composite regional center in Kashmir for the Ministry of Social Justice. On the roof is tapered at a particular angle from where the snow can fall on its own without any mechanical cleaning or without any physical cleaning. So, so this building works really well because no cleaning is required during the snowfalls. And plant shape is a swastika, and on the below picture is a Google image of this. And there are certain technologies. Nowadays, there is no need to cut the trees. Trees can be replanted. And in India, it is happening. In Varanasi, the waste plastic is used in the construction of roads, and that makes the roads last longer, and that makes the roads waterproof. Energy can be generated through the pavements, and these pavements can be made of recycled rubber, and this is being experimented abroad. Solar towers, research is going on solar towers. These disc-like objects, they are operated with sensors, and they face the sun direction to get maximum solar energy, because in towers we don't get enough space to put solar panels. So this new model is being experimented. In many projects in Germany and in Finland, the cladding is made of solar panels, railings are made of solar panels, and even glazing is made of solar panels. The conclusion of my talk is that India is a huge country, and we need to design buildings according to the climatic conditions of that particular region. And by so doing, we can be contributing a lot to save the Mother Earth. Thank you so much.
Thank you so much, Architect Surendra Baga. So we all know that India is a huge country, and which has 5 different climatic zones as presented in this talk. So each zone has its own design parameters, and architects and engineers should design buildings to suit the local climate zone rather than copying Western traditions or materials. Sir actually gave very good examples from different part of India, just like Varanasi and tree plantations. There are certainly many or more options too. So thank you very much, sir. For our next presentation, I request Engineer Balkar Singh, retired Joint Director, PEDA, Chandigarh, to give his presentation on star-labeled electrical appliances. Sir has more than 32 years of work experience in technical, managerial, and academic in the field of civil engineering, renewable energy, efficiency, construction and technology and management, green building, ECBC, ENS, E-audits. He retired as Joint Director, Punjab Energy Development Agency, Chandigarh, on 31st August 2020 after attaining the age of 58 years. He also worked at various important positions in this organization. He is recipient of State Award, Punjab Government Parman Patra conferred by Honorable CM Punjab for the exemplary services rendered in the field of science and technology at the occasion of Independence Day on 15th August 2011. He is also recipient of Award of Distinguished IEI Graduate Engineer conferred by the Institution of Engineers India on October 30, 2019. We have Engineer Balkar Singh from PEDA. Over to you, sir.
First of all, I congratulate PEDA, Bureau of Energy Efficiency, and IEI, Indian Institute of Architecture, for celebrating the Energy Conservation Week.
I think, sir, the voice, you have a little glitch in the voice. Can you please notch it up?
Voice is not coming?
No, sir, it's a little muffled.
Now?
Yes, sir.
Hello?
Now it's
Am I
better. Now it's
audible?
better. Yes, sir.
Am I audible?
I have a confirmation from other audience, Baga sir.
Hello?
ठीक है ठीक है
Ji, sir. Yes, sir. Start, please.
Okay. So, first of all, I thankful to PEDA and IIA for giving me an opportunity to talk about star labeling electrical appliances in this webinar. So, first of all, I would like to tell you that Bureau of Energy Efficiency is a central agency for implementation of energy conservation and 2001 in the country. And the main administrators are giving star labeling. So Bureau of Energy Efficiency itself has many portfolios like as awareness. It is creating energy conservation award, printing competitions, designated agencies, and in building energy conservation building code, demand side management, agriculture and municipal demand side management, and most important is the national mission for enhanced energy efficiency, where the industry is covered under the Perform, Achieve and Trade program. So we will talk today regarding star rating of appliances, which is given at A. So first of all, we should know why star labeling. There is a wide variation in energy consumption by products of manufacturers, and information on energy consumption is often not easily available, sufficient or easy to understand from the nameplates. Therefore, lead to continued manufacture and purchase of inefficient equipment and appliances. Therefore, star rating comes in. Historically, it starts first in Poland in 1962. Worldwide, 65 countries are implementing this star rating program, like Australia, Canada, China, Brazil, Thailand, Japan, and United Kingdom. But it starts in India in 2006 when voluntary star labeling was started in India. So, what Bureau of Energy Efficiency star labeling says more star, more saving, because the star rating is given from 1 star to 5 star. So 5 star is the most energy efficient appliances. Efficiency parameters are given on the label. Brand and model details are also given on the label. Technical parameters, applicable dates of standards and manufacturing years. So we'll discuss one by one in the next slide. So these are type of labels. This is for air conditioning, this is for refrigeration, and this is for distribution transformers. And likewise, this is for LCD, LED, and this is for the tube light, last one. And on right side, it is for submersible pumps. So when we see the description On the label, first we see the stars, 1 to 5 stars, and how much star are red. This we know that this is 3 star, 4 star, 5 star. So this is the level of 3 star. So likewise, there is a electricity consumption given over here, like at 248. This is EER, energy efficiency ratio, where you can see the efficiency of a product. In next description, you can see the label period. Label period is given over here, like
बलकार सर, आपकी आवाज बंद हो गई है। बलकार सर, बलकार सर, आवाज नहीं आ रही आपकी, प्लीज।
now is it audible?
हाँ, अब आई।
Yeah.
सर अब आ गई, बीच में बंद हो गई। हाँ जी, प्लीज।
You can
Ji,
see
sir,
the
now you're
technique.
audible. Yes,
Yeah.
sir, now you're audible.
Okay. You can now see that there is a technical details over here in the last column, last rows, type, gross volume, and the storage volume. And then there is a unique code in the logo, in the bottom of the logo. And these are some applicable conditions given in the label. So these are required to be checked while purchasing, while procuring the electrical appliances. Next, when we see that the time period of this labeling, and this labeling is being upgraded time to time. Like as this is a frost-free refrigerator star labeling, you can see that it was started in 2006 to 2011, and stars were given 1 to 5 star. And then it was revised in 2012, and 5 star became 4 stars. Then it was revised in 2014. Then 5 star becomes the 3 star. Then it was revised in 2016. Then you can see that first 5 star was, then 4 star, then it was 2 star, then what it was, now it is made as star 1. So you have to check the validity and star labeling, and it is being upgraded. Likewise, in room air conditioner, it was started in 2066, and now you can see that 5 star, then 4 star, it became 3 star, then now it becomes 1 star. So likewise, the improvement of efficiency is being considered by the technology enhancement, new technology is coming, and energy efficiency of the product is being increased, and it is being revised time to time. In this, you can see the same in window air conditioners from 2006 to 17. Then energy and cost saving. When you are checking the energy and cost saving, most probably 1.5 ton split air conditioner or window air conditioners are being used in normal cases. And you can see that in this 5 star, EER is 3.5. and its cooling capacity in watts is 5,200, and input watt is 1,486, and it consumes electricity per day, 12 unit per day. 12 unit per day. If we get per unit charge is rupees 4, then electricity cost comes to 1,440. And from this we can calculate how much cost saving per year. So we can deduct from the base star to 5-star. Then we can calculate by taking 5 to 6 months of running of this air conditioners. Then it comes out to 3,000. So if we in the state of Punjab we have per unit cost of more than 8 rupees, then we have a saving of 6,000 and above by using this 5-star. Secondly, when we are using this star rating, we have to see how we can choose at which place is air conditioning is working. If we are using in bedroom, then bedroom the running time of the air conditioner is about 9 to 10 hours. But in drawing rooms or living rooms, it reduces to 2 to 3 hours. So we have to select which air conditioner, which star rating is suitable for which place. So in this, if the running time is lower, we can go for lower star rating. Like as in drawing rooms, we can install 3-star rated like this air conditioner. But in living room, but in bedroom where running time is more, we have to go for 5-star. So this is the procedure how you can select the star rating of the equipment, and how you can calculate the saving by it. So transformers, distribution transformers also being rated from 1-star to 5-star. It is being rated through by taking the maximum losses at 50% loading and maximum losses at 100% loading. So this was valid up to 2017. Now it has been revised again. So in 2017, the 4-star rated appliances was made mandatory. Distribution transformer was made mandatory in the state of Punjab, where the consumption of this 16 kVA was 135 and 440 100% losses, and 135 and 50% losses. So this now has been revised as star 1. You can see that see here 16 kVA distribution transformers on 50% loading in the 135 to 440. Then Government of Punjab has revised this mandatory usage of this distribution transformer to 2-star. Now 2-star is mandatory in the state of Punjab, and for which if we use 200 kVA distribution transformer, then their losses should be 670, and in 100% load is 2,100 kVA. You can say standard in what standard losses should be such that. Now it has also increased from 200 to 2,500 kVA transformers. It was only for kVA transformers. So you can choose transformers as per the star rating, and you can choose any transformer more than 2-star rating in this, where you can get 5-star star transformer and get more energy saving in this. So when we are using ceiling fan, so in ceiling fan, there is air delivery given on the fans. Then base power consumption is given. Then star rating is given. Then energy saving, you can calculate cost of saving. You can calculate how you can calculate. This is the example. Here you can see that if air delivery is 220 cubic meter per minute, the service value is 3.2. Then power consumption is 69 watt. So 220 air delivery, then power consumption is 69 watt in base case. Then in 5-star, the consumption is 55 watt. Then operations, you can take 12 hours per day for 300 days. Then energy saving is 51 kilowatt hour per year. So cost saving for 5-star is 255 rupees. So you can calculate easily from this any equipment according to the rating, according to the running of the equipment. So the journey of this star rating was started when the Energy Conservation Act was enacted in 2001-2002. First voluntary star labeling was started in 2006 for refrigerators and air conditioners. After that, in 2007, 12 appliances was included on as voluntary appliances. Then in 2010, 4 appliances covered in mandatory labeling appliances. Mandatory means there should be no non-star rated in the market. So these are room AC, frost-free refrigerator, tube light, distribution transformers. So these were up to 2010. Now it is 10 mandatory appliances after the 2018. So next is the list of this B star labeling appliances, where you can see that the list of 26 appliances which has been star rated from 1-star to 5-star, and out of this 10 is one is frost free refrigerator, is it mandatory from 2006, and made mandatory, voluntary was given in 2006 and mandatory given to 2009. From 2009 it was made mandatory for the refrigerator. Then tube light is mandatory, then room air conditioners is mandatory, then direct cool refrigerator is made mandatory in 2016, then distribution transformer in 2009, and color TV is now recently made mandatory in 2016, then electrical gauge in 2016, then room air conditioner 2015, then now room air conditioners variable speed was made mandatory in 2018, and LED lamps are also made mandatory in 2018, and rest are voluntary appliances. You can see non-star also, but which are mandatory, you cannot see the non-star in the market. So this is the website of Bureau of Energy Efficiency, that is www.bwstarlabel.com, where you can log in and see the details of the appliances, like as manufacturer, which is the manufacturer, then its details and its consumption, and you can also compare it on from product to product. And you can also log in on the mobile. There is an app BE Star Label, which is available from Bureau of Energy Efficiency, and you can get the information on mobile also. So like this, search and compare, you can search any product and their manufacturers and compare it with the other manufacturers. So each information is available on the Bureau of Energy Efficiency website. This is the website, bestarlabel.com, and you can log in and get the information regarding its labeling details. So I would like to show you a video which shows you how you can purchase the this electrical appliances from the market, and it is a very beautiful video. You can enjoy that.
In India, one of the world's fastest growing economies, with the demand for appliances that make people's lives comfortable is increasing in step with the growth of the Indian economy. With the rising demand, the Indian market is flush with choices of consumers, with dozens of brands and dozens of choices.
We need to buy a new fridge.
I can't deal with this heat. I need a new AC.
I want a big TV.
I want to use appliances which will not only bring down my electricity bills, but also be good for the environment.
I need something which is efficient and something which is effective, something which doesn't make my electricity bills touch the sky.
The features that I'm looking for are that it should have a good picture quality, it should consume less energy.
Buying an appliance is about more than just the initial cost to purchase. Appliances also cost money to run. High levels of energy consumption also contribute to climate change by releasing more carbon dioxide into the environment. It was to tackle this specific issue that the Government of India passed an Energy Conservation Act in 2001, leading to the establishment of Bureau of Energy Efficiency to work towards conservation and efficient energy use. One of the key thrust areas of the Act is the Standards and Labeling Program, which was launched to promote production of efficient appliances and equipment and to facilitate informed decision-making for consumers. The BE Standards and Labeling Program allows consumers and manufacturers and retailers to produce, sell and buy energy-efficient appliances. The star rating on a product affects the efficiency of the product. A 5-star appliance will be highly efficient. At the bottom of the label are the other important product specifications: brand, model, type, capacity and efficiency. Each label has an energy efficiency parameter to define the star rating. Sunita wants a brand new TV. Dhwani needs a new air conditioner this summer, and Sanjeev needs to replace his old fridge.
Inverter ACs which are coming with a star rating of 3-star and 5-star, which are almost 25 to 30% more energy saving products. If the AC is running for 8 hours and if it is going for a 6 month in a year, so if it is running for a 6 month, then you are recovering that cost altogether in a 1.5 year.
ये इन्वर्टर सीरीज भी है और 5-स्टार भी है, बिल्कुल इसमें सेविंग्स और ज़्यादा होंगी, बिल्कुल ज़्यादा होगी, उससे आप ज़्यादा सेविंग कर लोगे शायद.
Retailers can direct consumer decisions towards efficient appliances and can recommend the right products that will save energy and reduce costs.
We have launched a standards and labeling program, which is basically a star rating program. 21 products are already covered under this program, and 10 of these are mandatory labeling now. The last one was the LED bulbs, which have been brought in under this program. So these star labeling means the higher the star rating, the higher, less the energy usage. It saves a lot of energy, so it's a win-win situation for the consumer also.
The B Star Label app is a platform where the consumer can access all relevant information about different registered products. The mobile app provides real-time information. It also tells consumers how much money they can save if they buy a 5-star labeled appliance as opposed to an unlabeled one.
In future, Bureau also wants to add some more appliances like washing machine, microwave ovens, so that the consumers will have a wider choice for their appliances.
There is a perception in the market that appliances with higher star ratings are more expensive. But in reality, the purchase price of an appliance is just one part of a long-term cost incurred, and the expense of running a less efficient appliance will lead to larger electricity bills over the years.
We have to be conscious ourselves. We have to go and switch off that one power point or charging point or whatever's on.
In the long run, in the beginning, you may have to shell out a little more.
Sure.
But in the long run, you save much more. So I look for the B label, especially the 5-star rating.
The stars always.
Simply leaving appliances on standby mode uses energy even if they are plugged in and not being used.
All switches must be turned off. You will be amazed by the amount you can save on your electricity bills by these simple measures.
Let's make it as a movement to buy products rated and are energy efficient and save energy.
I also appeal all the retailers and dealers to convince their consumers to select for higher efficient appliances whenever they are going for a new appliance, so that as well as the country.
We are consumers and we are obviously part of it, and we should be doing our own bit.
Energy saved by me can be consumed by others.
I also want to ensure a better, cleaner, healthier environment for my children.
Here's what you can do to make a difference. Completely turn off all appliances when not in use. Buy only star-labeled appliances. Invest in a higher star-labeled appliance to save money in the long run. For more details, please refer to BEE's website, bstarlabel.com.
I trust the B label.
I trust the B label.
I trust the B label. I trust the B.
Use B Star Label appliances, save energy, save environment, and save Earth. Thank you very much.
Thank you so much, sir. This was our engineer Balkar Singh. And star labeling is actually really important, as sir told in his presentation. We should all buy the star labeled appliances to save much more on energy and then on bills. When we go buy any electrical home appliance, we know that star labeled, 5-star labeled is highly energy efficient and highly recommended. More stars, more the saving. And sir has educated us all on the star rating of the appliances, such as for the TVs, ACs, refrigerator, tube lights, etc. He also taught us how to actually, read and decipher the ratings. It was really helpful, sir. And we have to be really wise while buying these appliances. So I request all the attendees again to please fill the feedback form at the end of the session, which will be just taking 5 minutes of your time. It has 10 to 12 questions in yes or no format, and which are pertaining to the lectures and webinars and our talks. Your feedback is really essential for our future webinars. So kindly please fill the feedback form. Then for our next presentation, we have Engineer A.C. Verma. He's an HVAC consultant. He's a highly dedicated and experienced energy management, GREHA certified professional with high aptitude for integrating design of energy efficient sustainable facilities, having more than 32 years of experience in planning, design, construction, and management of complex and green defense facilities He has an integrated and systematic approach to high-performance facilities design and operations as to optimize the facility's green and resources saving potential. He is a greenhouse certified professional, DEE National Certification, Energy Auditor and Manager, APO certification in green productivity and energy management implementation. He is FICCI course in advanced energy audit techniques. He's certified in that. He has done IGBC and TERI courses in green building rating systems. He's also served in many appointments during Director Green Building Projects and Director Design and Consultancy, contributing to energy efficient building systems, design, planning, and final execution and management of defense of infrastructure projects. He's also being associated as visiting faculty with Jamia Millia Central University for master's program in architecture, and he will be enlightening us on new design options to reduce building HVAC energy. Over to you, Verma sir.
Thanks, madam, and a very good afternoon to everyone. I am A.C. Verma. After this three very interesting and juicy presentation, it is now my turn to share a few dry facts about new challenges in HVAC ventilation design, especially with reference to the growing need for higher outdoor air requirement. So let me first share the screen first. Is the screen visible, madam? Hello?
Yes, sir, your screen is visible. Yes, sir, your screen is visible. You can start now. Yes, sir.
So my topic today is new design options to reduce building HVAC energy, but rest assured, there will be no mathematical calculations to involve you in the engineering design. The objective of the presentation is to familiarize you to the emerging concept of equivalent clean air approach in HVAC ventilation design. During this COVID pandemic, there has been recurring demand for higher and higher outdoor air supply to air-conditioned spaces, thereby having negative impacts on HVAC energy cost. So it is in this context, if we adopt equivalent clean air approach, it will help us to reduce energy cost, which while still controlling viral transmission with minimum amount of outdoor air. So I will discuss the subject in following sequence. The energy challenge in HVAC ventilation design, and then I will explain the concept of equivalent clean air. And to implement this equivalent clean air concept, a few alternative design options of like IAQP method or hybrid method to make it more effective, and then the potential, energy saving potential of this IAQP method, and of course I conclude. So new challenges in HVAC ventilation design. The HVAC consumes almost 50 to 60% of total energy consumption in a commercial building. And out of that, 25 to 30% is consumed by the HVAC ventilation system. So what is the best way to save energy? Naturally, the natural ventilation is the most energy efficient solution. And even 20 years back, 25 years back, we used to see in places like Shillong, the HVAC system having the free cooling provisions. But natural ventilation has its limitations like site and architectural constraints, outdoor air pollution, which is growing day by day, the outdoor temperature and humidity fluctuations daily and on the annual basis. So the alternative is to provide mechanical ventilation, which is an integral part of HVAC system. But when the threats of COVID-19 suddenly loomed over us, there was a need to replace the recirculated indoor air with higher outdoor air changes. And to beat this challenge, our existing systems proved very inadequate because they were not designed for the higher outdoor air, because you take out more outdoor air, the plant capacity will be strained. So, and even if those who can try to match to its best, had this problem of the rising higher energy consumption. So this rising higher consumption became a big concern, even in places like USA. So today, the new challenges in HVAC design are to enhance indoor air quality in air-conditioned spaces. Today, the health and personal health and safety has become the prime concern of every individual. And second, the increase in energy consumption due to higher outdoor requirement needed to enhance the indoor air quality. So why our systems are not designed to match the higher outdoor air requirement? Most of the systems are designed for the minimum outdoor air required based on the ASHRAE standard 3.1 ventilation rate procedure. And this one is a prescriptive procedure, which is depends on a few factors like the space type, it's a space application, occupancy level, and floor area, and of course ventilation effectiveness. And a very simple calculation can determine the minimum outdoor air required. And if you can see on the screen, the formula, that design occupancy, which depends on design occupancy, outdoor air flow rate per person as is specified in the ASHRAE standard, net occupiable floor area, and outdoor air flow rate per unit area. The logic is behind this thing that you require minimum outdoor air to compensate for the fresh breathing air required by the occupants in the space. And second element was the pollutant contaminants generated by the building interiors. But situation like this COVID-19 or the viral load has not been considered so seriously. So to minimize the impact of higher outdoor air requirement, the concept of equivalent clean air approach has become getting prominence. So you can see what is this equivalent clean air approach. You can see from the sketch on the right that this is a HU where the outdoor air is coming and recirculated return air is coming. Now, if the normal cases, the outdoor air has minimum required outdoor air is provided. So when this viral load has increased, you require more outdoor air, and more outdoor air consumes more energy. So in that case, suppose you require to get this control the viral load, the bacteria and viruses in the space. Suppose you require 1000 CFM to attain the 3 air changes per hour in the space, outdoor air. Presently, suppose if you want 1000 CFM, and then if you add to this HU, this air cleaning technology, filtration and air cleaning technology, these air cleaning technologies will offset the additional requirement of outdoor air. So your outdoor air is reduced. Outdoor requirement reduces, and in that case, whatever, suppose you have from 1000 to you have reduced it to 300 CFM. So that 300 CFM becomes the equivalent clear air, is a equivalent of 1000 CFM clear air, which you require if you are going by the normal approach of minimum indoor air required, minimum outdoor air required. So if you it is like a equivalency of actual outdoor air, which in combination with filtration and air cleaning technology will deliver the same ventilation outcome as provided by the high quantity of outdoor airflow without fine filtration and airing. And you can see just in the formula below, that is the ACH, that is the air changes per hour, total air, indoor air replaced per number of times in 1 hour. That is the equivalent you can find out from the ACH of outdoor air, the actual air which you are supplying, plus the actual air equivalent of the filter and actual air equivalent of the air cleaning technology efficiency, based on efficiency. So advantage of this approach is that the focus now shifts from on viral load reduction, not on increasing outdoor air quantity, and how we are going to reduce it, that will depend much on the air cleaning technology you adopt. And this will provide us lesser energy consumption due to reduction in outdoor air. And the recent ASHRAE new guidelines which have been issued only last month, if you say, prominently highlights the equivalent clean air supply approach, because it is based on the ASHRAE core recommendations for reducing airborne infectious aerosol exposure is based on equivalent clean air supply approach, which depends on the ventilation, filtration, and air cleaning technology, subject to the constraints that the energy should not increase exorbitantly. So that is the flexibility has been provided now to manage the outdoor air requirement. And just for information's sake, that is this guide core recommendations stipulates that at least required minimum outdoor air flow rate should be provided and maintained as specified by applicable codes and standards. This can be achieved by combination of filters and air cleaners to achieve MERV 13 filtration level or better level of performance. And this air cleaners are going to play a major role, but we have to take care that it's the solution which we develop is not a constraint on the energy, means not a burden on the energy consumption, but it minimizes the associated energy penalties. And two more points which needs to be highlighted, that earlier we used to have the demand controlled ventilation to reduce the outdoor air requirement at that time. But now if you see in the guidelines, the maintain equivalent clean air supply required for design occupancy. So we have to maintain the air supply as per the design occupancy at all the time. And here the equivalent clean air supply will be very valuable to solve the problem. So to implement this clean air approach, equivalent clean air approach, there are certain alternative ventilation design options which can prove to be effective. And one of them is the ASHRAE standard 62.1 indoor air quality procedure. This is the ASHRAE prescribes both the method, the ventilation rate procedure, which I just explained to you a few slides before, and second is the indoor air quality procedure, and this is the performance-based design procedure. And in PVC, we have the prescriptive approach and we have the building approach. So here also, this is the prescriptive approach, is the and the performance-based approach is indoor air quality procedure. So this one, if you see, depends on the compliance, depends on the objective evaluation and subjective evaluation. Objective, the physical testing, and then you have a subjective survey also, verification. So IOQ testing is done, and then the survey is done, survey of occupant survey is done, or its comparison to the similar type of building designed on the indoor air quality procedure basis. This is done because any you take any smell or any impact of any gaseous contents on different persons may be having different. So it is a survey is carried out that 80 to 90% people are satisfied with the level of cleanness achieved, then it meets the requirement. But at the same time, have to be physically to see that it meets the criteria of laid down as per the concentration. Design has been done by the VRP method, and operation of the system is done by the IOQ method calculations. Because in that case, because IOQ method will require lesser outdoor air requirement compared to the VRP method, and in that case, you have the flexibility to increase the outdoor air supply to the maximum maximum minimum air requirement. And this is the one case study, because this method has been being used in different places, but on very selective basis till now. But the COVID-19 has changed the game. So this is the example of a IOQ-based energy saving. This is the building in the Duke Energy Center in the North Carolina, USA, and it is a LEED Platinum certified building. It is a 240-meter tall building, and 54 floors are there. But everybody talks about the PV panels installed there, the water efficient fittings are there. So all these things are people talk about, but the HBS ventilation system has a very special provision in this building, because when this building was being designed by the LEED Platinum certification building, the owner of the building has two requirements. He wanted this building to be certified as a LEED Platinum. And he said that to reduce the energy consumption of such a huge skyscraper, the energy consumption should be, to reduce the energy consumption, the IAQP method, the indoor air quality procedure method, should be adopted. Now there was a problem. The green building code, the LEED green building at that time did not have the provision for the IAQP method. They were only accepting the VRP method. So they were not ready to certify it as the LEED Platinum. So the consultant, what the green building did, they designed the building based on the VRP method, ventilation rate procedure method, and once it is certified, they have done the calculation also based on the IAQP method, where the lesser outdoor air is required and better indoor air quality can be provided to save the energy. So this is the one case of a hybrid method where predominantly it runs on the IAQP based energy saving. These are a few other energy saving cases done by my colleague in business associate in USA. This is the, you can see this is the middle school at the Indiana, 1 lakh square feet. And by adopting the IAQP method over the VRP method, almost 24,000 annual energy saving for this has been achieved, and payback period is less than 30 days. Similarly, for another school, of 1,20,000 square feet, because the health and wellness of the children are very important, so the schools are mostly adopting to these technologies. So annual energy saving is 30,000 and payback period is 24 months. And similarly, the airport in Indiana state has been done by my colleague, and that is the energy saving leads to $35,000 and payback period is less than 2 months. Similarly, for a sports center, it is saving 33,000 at the payback period of 12 months. And for a hotel project, it has become to 18,600, payback period is less than 18 months. The same technique, the same procedure, we also tried in one of our project here, for an auditorium building, and the design value for that, when we worked out with the VRP method and we worked out with the IAQP method, we found that there is an outdoor air reduction of 31% is feasible and cooling load reduction of 23%. So annual energy saving is coming to 3.3 lakh rupees. And if we consider the cooling load, the gains from the cooling load reduction, then the payback period is around 15 months. So this these cases explains the potential of the indoor air quality method to implement this equivalent clean air approach. And here we have seen from all this data, we see that incremental cost of healthy indoor air quality is almost zero, because the cost of the air cleaning equipment technology is recovered by the energy saving. And if you take the potential gain in productivity improvement, it will be 4 times more. So to conclude, you see that equivalent clean air approach will reduce higher outdoor air need. And this can be effectively implemented through the IAQP plus air cleaning technologies, which will deliver energy cost reduction and safe indoor air. And these techniques can make our HVAC system energy and efficient and resilient to meet the future challenges. Friends, we must remember that this virus does not differentiate. The virus like COVID-19 does not differentiate between rich or poor, high or low. But this deadly killer virus definitely has preference for people occupying the air-conditioned spaces rather than compared to the people in the non-air conditioned spaces. So now the challenge is for us as building professionals to make a healthy indoor environment a priority in our design and in our operations. Thank you very much. If I have any clarification or question, I would like to explain.
Thank you so much, sir. That was a wonderful presentation. Sir's presentation has been very informative and enlightening. HVACs have become an important part of our today's lifestyle, and because of the harsh conditions in many zones of our country, as we learned in the first talk by Bhaga sir, and the concept of star labeling of appliances surely helps, which was in the last presentation. So we as consumers should choose 5-star rated ACs as they consume less energy, and even if they're costly, the payback period is definitely seen in the following years and helps in saving energy and on bills. And even Verma sir's presentation actually, enlightened us about all the procedures. So thank you so much, sir. That was actually very informative. And we have a feedback form in the chat box. So I would request the audience to log on to the forms and kindly fill it. Please, it's just a 10 to 12 question feedback form, which will take hardly 2 to 3 minutes in a yes or no format. Thank you so much. And now we have a few questions in the Q&A chat box. So I request Architect Surinder Bhaga to please answer these questions. There are a few questions in the Q&A. Architect Surinder Bhaga, shall we start?
Yes, ma'am. The first question is, according to you, what are the future prospects of adopting large-scale hydro fuel-based automobiles? Though this question is a bit out of syllabus here, because we are here catering to mainly the building sector. But anyhow, so far my little knowledge goes about this. Hydro fuel-based automobiles is one of the options. Many companies like Toyota are experimenting with this idea. Many car makers are committed to making hydro fuel automobiles. But there are at the same time some studies are showing contradictions as well, because one of the studies says that it produces more carbon dioxide than normal vehicles. So technology is not available, manpower is not available, and a country like India, I think it will take lot of time to reach that level. And I would like to just share one small experience. We are doing a large scale project in Haryana state, where there was a requirement from the Haryana government that we need to have a facility for electric charging of the vehicles. And I have tried a lot. There are very few companies who are into this, and there are not even experts, and hardly anything is available. So we faced a lot of problems in designing that project, where कितने चार्जिंग स्टेशन लगने हैं, कहाँ लगने हैं, क्या नॉर्म है, किस तरह से तार आएगी, nobody knows about it. So we have not reached to that level. And to my knowledge, first time in India, there was an exhibition on electric vehicles, which was held in Prakriti Maidan, Delhi. It was organized by Udan Media. And अभी तो electric vehicle का ही नहीं हो रहा है, ये तो उसके भी आगे की बात है. I think it will take a lot of time. Yes. Next question is.
Sir, may I add?
Yes, sir. Verma ji.
Sir, may I just add one point for the information?
Yes.
That as regarding this use of the hydrogen fuel in the automobiles is concerned, I will just like to share that in this may be feasible in future, because recently that certain reports have come where in the Germany the trains have been on the demonstration trains have been run on the hydrogen fuel. And in this budget, if you have if people have listened to that thing, the government has given a special focus on the developing the hydrogen as a fuel. So it may be possible in the near future.
Yes. Yes, sir.
Thank you.
And next question is, how would the use of thermal resistant materials in construction affect the quality and tensile strength of building, and how feasible it is in an eco-friendly techniques of infrastructure? I think thermal resistant materials are like any normal materials. I don't think it will have any negative or positive impact on the tensile strength of the building. And sir, India में more technology क्यों नहीं है? I think we don't agree with this. India has lot many advancements in technologies in many fields, and most of the things are already available here. And with this, the questions are answered, and now we can move to the next section, please. Hello, Ramnik. Ramnik got disconnected. I think may I request Harveen ma'am to give the concluding remarks and present vote of thanks.
Yeah, sure, sir. Thank you, sir. Good evening, all. Once again, after listening to all the expert talks today, I think the mission for today's talk has Architect Baga has very rightly advocated that Indian architects should design buildings to suit local climatic conditions rather than copying the Western ideas blindly. Sir has elaborately explained through his own design considerations for various climate zones that should be followed to make the buildings energy efficient. Engineer Balkar's topic was very relevant again. He highlighted on the importance of using star-labeled appliances to conserve energy. Engineer A.C. Verma spoke on ideas to save energy in air conditioning. We all know nearly 50% of energy consumption in buildings is related to air conditioning alone. He shared his vision to save electricity for doing air conditioning in the projects. The message from all speakers is crystal clear that we should all save energy, save environment, and save Mother Earth. It is my pleasure to propose a vote of thanks for the contribution of each and every one for having made this webinar a memorable event. On behalf of the entire team, on behalf of Sakar Foundation team, I would like to express deep gratitude to the Punjab Energy Development Agency for giving us this opportunity to meet, exchange knowledge, exchange ideas. A very special thanks to all the officials from PEDA for their valuable support. I'm also thankful to expert speakers, Architect Baga, Engineer Balkar Singh, Engineer A.C. Verma, for their rich presentations. Again, grateful to officers and staff of Housing and Urban Development of PEDA, Gamada, Amritsar Authority, Bathinda, Jalandhar, and Greater Ludhiana Authority for their participation in this webinar, and all other professionals for attending the program, and especially Sakar Foundation that all this information reaches the masses. We are grateful to office bearers Punjab and Chandigarh chapters for supporting this program. Special thanks is due to all of you for spending your valuable time and attending the event and being such patient listeners. Thank you very much. Last but not the least, I would also like to thank Architect Ramnik for hosting this event very patiently and very ably. Deep gratitude to all the media personalities for their wholehearted support for this program. Thank you very much.
Thank you. Thank you so much, ma'am. So we are really delighted to have all of you here with us. It is a simple fact that the world's reserves of fossil fuels are running out. And depending on the rate of use, and therefore, if the consumption of these forms of energy are reduced, the existing reserves will last longer. The largest improvements in energy conservation in the last 2 decades are projected to take place in India, China, and European Union. And energy conservation offers benefits at different levels of the economy. And yes, we actually see people are moving towards energy efficiency. It's certainly examples were shown in the presentations and talks by our eminent speakers today. So the amount of worldwide energy reserves and life is variable according to the source of information used. And the earth provides enough to satisfy every man's need, but not to every man's greed. As Gandhiji has said, there are some really hard facts on why energy conservation is a must, because most of the energy cannot be reused or renewed. And we save the country a lot of money when we save energy. An old saying describes in a way that the earth, the water, and the air are not a gift to us from our parents, but a loan from our children. So it's rightly said, and hence we actually have to make energy conservation a habit. It is our bit as a good citizen and our efforts which will really be helpful in saving our environment. I would again like to congratulate PEDA, Sakar Foundation, and BE for letting us encounter this very informative event on energy conservation. Lastly, I would even like to add that BEE also broadcasts radio programs Bachat Ke Sitare, Dost Hamare on Air FM Gold in 20 languages, which spread awareness about star-labeled appliances in India. I hope you would tune into that channel, and also an app which was introduced by engineer Balkar Singh in his presentation, which is to check the performance of your star-labeled bought appliances. And I would like to thank all our eminent speakers, our supporters, and our kind audience for here being with us. And again, a request to all the attendees to please fill the feedback form which is in the chat box. It will be really a great help to us. And then I would also like to add in the end that energy efficiency works better if first and second BEE laws are implemented together. First law being buy energy efficient, and second BE law being be energy efficient. So thank you everyone. Hope you have a remarkable day ahead. Feedback form is in the chat box. Kindly please link on to that. Thank you so much. I request the attendees to fill the feedback form. The link is open for another 10 minutes. You can log into the feedback form. It is just a 5 to 7 minutes form. Kindly please fill into it. Thank you so much, everybody. Hope you have a remarkable day ahead.